So, good morning, everyone. So, my topic is earthquake waves, and yeah, let us just basically we're gonna split this session in two parts. One first, at first, we'll know about what is earthquake, and then we will know about what are waves, particularly earthquake waves, which are known as seismic waves. So, yeah, now, what actually an earthquake is to a layman, or we can say in a layman language, it is basically shaking of the earth, which is due to the release of energy within the earth, due to which we can feel faint tremors to the motions which are wild enough to destroy or displace roads, to destroy big buildings and a very good infrastructure of a city. And the energy released, the magnitude of this energy released is measured by the Richter scale, which is a logarithmic scale. Let us just I'll just try to explain it through a theory which is known as elastic rebound theory. Now, okay, this is a basically this is a rock, right? Now this rock has certain properties. It has its strength, its ductility and everything. Now there is a compressive strength. Compressive means that opposite on both these sides, like it is basically compressing the rock structure, right? Now this pressure is applied from both the sides, and to adjust to this pressure, this rock tries to modifies its shape, and to basically in response to this pressure, the rock is exhibiting its ductile properties, right? It's exhibiting its ductile properties. It's and then after a certain limit, this rock breaks down its elastic limit, or we can say this is basically a curve in which the rock tries at this point of time, or at this point of time, up to this point of time, the rock tries to adjust to this compressive force, but after that it ruptures, right? It ruptures, its plastic limits is reached, and it ruptures. And when it ruptures, now when the rock basically move or displace with respect to this rock body, or this rock structure, move past this rock structure, or displaces relative to this rock structure, this is known as fault, right? And due to this fault, energy is released in this we can say it's a circular paths. Energy is released, and this energy is released in the form of seismic waves, which we are gonna study in this slide after a while. So this energy is released in the form of seismic waves, and this phenomenon is known as earthquake. And the point from where the energy is released is known as focus. And the point just above the focus on the ground, like this focus is under the ground, within the earth surface, this is under the ground, and the point just above the focus on the ground is known as epicenter. So we are going to use these terms. That's why I wanted to let you clear these terms here itself, right? So yeah, I think we got the idea now what exactly is an earthquake. So technically, or we can say a very technical definition of this can be is the earthquake is a form of energy of wave motion transmitted through the surface layers of the earth in widening circles from a point of sudden energy release, which is the focus. I hope this everything is clear now. right. Now this earthquake waves, we talk about that. Okay, the energy is released in the form of waves, and these waves are known as earthquake waves. And earthquake waves are broadly classified into two, body waves and surface waves. Now body waves are generated at the focus, while the surface wave are generated at the surface. Body waves move in all direction and surface waves moves along the surface. Let us clear this. Okay, let us just understand this from this diagram. Now this is a focus, right? This is a focus, this is a focus point, and from here the energy is released within the earth, within the basically and under the ground or within the surface of the earth. Now okay, these body waves, these basically travel in all direction, and when they interact or when they reach at the surface and interact with the ground, or when they contact the ground, they generate waves which are known as surface waves, right? So these surface waves are generated by the interaction of the surface with the body waves, and these just move along the ground only. This can't move within the earth surface, right? So this is known as surface waves. So surface waves are more destructive than the body waves, and these are basically proportional to density difference, or we can say their velocity is proportional to density. The more the denser the surface, the more will be their velocity, right? And now body waves are of two types, P waves and S waves. Now what are P waves? P waves are since their name implies, these are primary waves and these are secondary waves. They are first to arrive, and these are slower than P waves, and thus they arrive after the P waves. So first arrival is of P waves, second arrival is of S waves, and then arrival is of surface wave, and hence their amplitude, the P waves are least destructive, S waves are more destructive, and these surface waves are the most destructive. These P and S waves are body waves, these are surface wave, right? So surface waves are also further of many types, but due to time paucity I'm not covering those here. Okay, now this okay, the propagation is how they travel. These vibrate parallel to the wave propagation, and this vibrate perpendicular to the wave propagation, right? See, this is our P waves. They travel like this, they vibrate like this only, the parallel to the parallel to the wave propagation. So what it creates, it creates a pressure along the direction of wave propagation, right? And this is basically stretching, and this causes stretching and squeezing of the material, right? And the surface waves, these propagate up and down, these propagate, sorry, S wave or surface wave also, these propagate perpendicular to the wave propagation. If the wave is moving this words, like in this direction, then the surface waves are propagating here up and down, right? These are L waves or Rayleigh waves, we can say. And these are basically surface waves. We're gonna not talk about this much here, right? So these are P and S waves, and these are surface waves. The three of these waves propagate perpendicularly, and these waves propagate uh, parallel to the wave propagation, right? Now again here, this is a very important part here. Now the property of the waves, these travel through gaseous and liquid and solid material, and this travel only through solid material. This is this fact or this characteristics is going to help us a lot to infer about the earth's internal structure, right? So we do get a imprint, or do get the basically record of these waves on an instrument, with the help of an instrument known as seismograph, right? Seismograph is the instrument used where we can get the imprints of the P waves and S waves, and these are basically we recorded in a seismograph located at the far off places. but there exist some specific areas where the waves are not reported, and these are known as shadow zones. Right now, here is what is shown is that the seismograph located at any distance between 103 degree from the epicenter recorded the arrival of both the P waves and S waves. However, the seismograph located beyond 142 degree from the epicenter records the arrival of P wave and not the S waves. That means this is a shadow zone, S wave shadow zone, right? And thus between 103 and 142 from the epicenter was and here between 103 and 142 we do not get not even P waves nor the S waves. Now what does this tell about the internal structure of the earth? Now we know that the S wave passes only through solid. That means this outer core is liquid in nature. It has liquid properties, it is molten in nature. That's why S waves don't pass through this. And what the P wave shadow zone tells us about that okay, P waves basically refract when they transit from solid to or semi molten to molten state. So that means the mantle is in semi molten state and the outer core is in liquid state, or we can say molten state. So this has very wide implications. We know that earth do have magnetic field. Now why, from where that earth get generate though that magnetic field? The answer is the outer core, because the outer core is full of iron rich elements, iron, nickel, and those elements, and those are liquid in nature, molten in nature. That's why they have ions, and a magnetic energy of the earth is generated there. Earth's magnetic field is generated from there. So due to time paucity, I am not able to I covers this I'll cover this much topic only. I hope this is clear to you. So yeah, thank you.